Standard, still on function 2, known as the properties of function. We are currently going to look at learning target 1, which I can justify the slope is the same between any 2 points on a line. So we're going to look at this graph here to the side. It involves Joe and Kelly. So it says, use the graph to answer the questions below about Joe and Kelly's work. So in order to find the slope on a graph, Joe chose the points 0, 0, and 2, 4 to make right triangles. Draw this triangle on the graph on the right. So we'll pick Joe is in the red color. So you pick the point 0, 0, and you pick the point 2, 4. Now, points that you pick need to have be at an intersection of an axis. So for example, notice Joe picked that one and he didn't pick 1.5 and 3 because you can't guarantee me that's 1.5. Okay, that's even kind of iffy. It looks a little bit above. So these are 2 points he picked. We're going to make a right triangle. So we're going to do rise, or the change of the y's, over the changes of the x's. Okay, I'll put the right symbol there. So here's Joe's. I'll put a J just so we don't forget. So it says, using Joe's triangle, what is the slope of this graph? So remember, we can call it rise over run. We can call it the change of the y over the change of the x. So we're going to count how much change is on the y-axis. So 1, 2, 3, 4. So your y change is 4, or your rise is 4, and your run is 1, 2. And I look down here and I make sure that each box is really 1, and it is. So this is a run of 4 and a rise of 2. So we can write that, simplify it down to 2 over 1 by dividing both numerator and denominator by 2. And then sometimes people like to leave it look like a ratio, and then some people like to actually simplify it even further down to just say we have a slope of 2. It says Kelly, we'll pick blue here. Kelly chose the points 2, 4 also, and 5, 10. So Kelly's going to pick 2, 4 also, and then 5 and the point 10. So this is draw a triangle on the right here. So this is, we're going to go a nice little rise. And notice when I make this triangle, I go straight vertically for my rise, and then my run is straight horizontally. So my rise over my run, and then it's going to ask me, this one's Kelly's, it's going to ask me what is the slope. So rise over run, change of the y over the change of the x. So we're going to count how much change of the y it is. It's 1, 2, 3, 4, 5, 6. And for those of you that don't like to sit and count, you can also look at the axes here. It starts at 4, and then it ends at a change of 10. So 4 to 10 has a difference of 6. So if you're not into counting the boxes, that's another way to look at it. Here's a run of 1, 2, and 3. Again, you can look down. This is a run, so it's on the x-axis. So it starts here at 2, and it runs over here to 5. That is a change of 3. So 6 over 3. If we reduce that by dividing by 3 on top and bottom, we get 2 over 1. And then, of course, I said you can simplify that down just to 2 if you want to. So notice that they both ended up with the same slope. Even though they're not the same size, they have the same slope, which totally makes sense because this is a straight line. So it has a constant rate of change. If it didn't have a constant rate of change, it would like jig-jag around or be curved. But since it's a straight line, that means that the slope never changes. It's the exact same constant change, in this case, 2 over 1, the whole entire time. A couple questions here. Number 5, how are Joe and Kelly's triangles related? And explain how I know. Well, first of all, I can say their triangles are similar. Because to have similar triangles, we go again looking at this graph, to have similar triangles, you have to have proportional sides. So this proportion of 2 I should say, sorry, 4 to 2 is the same proportion as 6 to 3 because they both reduce down to 2 to 1. So their triangles are similar, and I'll write there that their sides are proportional, or their side lengths are proportional. Which again was, Kelly's was 6-3 and Joe's was 4 and 2. And then you can take it one step further. You can say they simplified, those proportional sides simplified to the same slope of 2 over 1, or you can write it as 2. So the triangles are similar, which means they are the same shape, but their sides are proportional. Explain why we could use any 2 points in the line to find the slope. Well, I kind of explained this before, that any 2 lines, it doesn't really matter because remember, this has a constant rate of change. So any 2 points, I'd be a little detailed with, that cross nicely. So any 2 points that cross nicely, you can use to find the slope. So for example, I can see this one crosses right here. So I could have made, or Kelly could have made, a slope like there. And you notice those are the same size triangle. Or you can even make a giant. So we could have went big, like from 0.00 all the way up to 510. That would be a rise of 10 and a run of 5. Well, 10 over 5 also is 2 over 1. So it doesn't really matter which 2 points you pick because the slope of the line is constant. Oops, sorry. So the slope of a line is constant, means it is changing by the same amount all the time, so it doesn't matter which 2 points you pick. So based on what you know, which of the following triangles would also lie on the line graphed above? So we're going to look at the proportions, or look at the change of the y over change of the x's. So A here, we'll just go change of the y over change of the x. So remember, change of the y is vertical, so that would be 26 over 14. If I divide both top and bottom by 2, it reduces to 13 sevenths, which is not the same as 2 over 1. If we try here, 36 is your rise, or your change of your y's. So 36 over the run, or change of the x, would be 18. Divide both of those by 18 and you get 2 over 1. So B works. And then we'll check this last one. The rise is 30. The run is 12. If you divide by 6, I think that's the greatest common factor of both, you get 2. 12 divided by 6 is 2, and 30 divided by 6 is 5, and 5 halves, because that's as low as you can go, does not equal 2 over 1. So, and we could actually take that down to prove it into a unit rate of 2.5 over 1, which is not 2. 13 sevenths, if I want to make that 1, 13 divided by 7, hold on. It's not even, it's approximately 1.86. So again, that's not 2 over 1. So my only triangle that works is triangle B, which had the ratio of 2 over 1, or simplified ratio of 2 over 1. Question 8 here says, draw two different sized triangles that could be used to find the slope on the graph and label the rise and run. Explain the relationship between the triangles. Okay, so we'll go ahead. I'm going to start at 0, 0, and I can see crosses right there. So you're going to make your slope triangle. So vertical line, which is your rise, horizontal, which is your run. So rise over run. So this one, you got to be careful because the axes are labeled by 2. So each box represents 2 here on the rise or the Ys. So 2, 4. So I have a rise of 4 and a run. If you look at the horizontal or the x-axis, it's going by 1. So that is 1, 2, and 3. So I have a rise of 4 and a run of 3 for my first triangle here. And then my second triangle, we'll go right there at 3, 4, and let's take this a little further up. See if it crosses. I say it's going to cross right there too. I like it when the graph goes all the way off the page. It's easier to see. So we're going to make this triangle. We'll call it the red triangle. So again, this is my rise. How much change in the Ys? So remember, I can remember these are going by 2. So 2, 4, 6, and 8. So my rise on my red triangle is 8. Again, if you don't like to count, you come over here and say, well, it started at 4 and ends at 12. The difference between 4 and 12 is 8. And then my run is going by a point of 1. So this is 1, 2, 3, 4, 5, 6. So we have 8 and 6 here. Again, look at the bottom if that bothers you. 3 up to 9 is a change of 6. So my run on my red triangle is 6. And if I reduce that by dividing by 2, so 8 divided by 2 is 4, 6 divided by 2 is 3. The relationship is that they both have the exact same slope again. So that means they're similar triangles, which means they're the same shape, and then their slopes are both identical, which doesn't surprise me because it's a constant rate of change because you have a straight line. So we'll write that up. So the triangles are similar. And the slopes of both triangles simplify. Whew, sorry about that handwriting. To 4/3. That is a graph entitled Ricardo. On the x-axis, we have time in minutes. On the y-axis, we have number of words. So our first step is to select 2 different points that make a slight slope triangle on the graph and then determine the slope of the line. So I'm going to pick 0, 0, which means it's a proportional graph. I'm going to go up the graph, which is an increasing graph. I'm going to notice it crosses again at 2 minutes and 300 words. So I'll make my slope triangle from there. So you're going to go vertically to make the rise and horizontally to make the run. And then I'm going to go look for what those values are. So I have rise over run. So I look on my y-axis, I'm increasing by 100, 200, 300. So 300, in this case it's words, over, and then my x-axis, or my run, is 1, 2. Again, I can look down here in the axes, notice that it's going by ones. So that's 2 minutes. So 300 words in 2 minutes, and that reduces down to the fractional amount of 150 over 1. So 150 over 1 is the slope, or the unit rate. Remember, you can also call this the change of the y over the change of the x if you prefer. B asks us to pick a different pair of points that will make a different sized triangle. So we don't want the same size, we want a different size. And then make the slope triangle on the graph and determine the slope. So I can start here at 2, 300. I'm going to go up. I would stop at 4, 600, but that'd be the same size triangle. So I'm going to go a little bit further, and it looks like a good one would be 6 minutes and 900 words. So I'm going to make that triangle here. And then I'm going to count what this rise and run are. So I'm going by hundreds on the Y. So 100, 200, 300, 400, 500, 600. Or if you don't like to count boxes, you can just look off to the side. I started at 300 words. I went up to 600 words, which is a difference of 600 words. And then count the boxes on the run. 1, 2, 3, 4. Or you can look below here, start at 2 minutes ending at 6 minutes, it's a difference of 4 minutes. So my slope is a 600 over 4. So 600 over 4, which is the change of the y over the change of the x, or my rise over my run. And if I reduce that, I'll just split in half or divide by 2, which would be 300 over 2, divide by 2 again, which would be 150 over 1. So notice that both the slopes, even though they started out to be different sized triangles, reduced to the same amount of 150 over 1. So what finally is the relationship between these two slope triangles? Well, the triangles are similar triangles. Remember, similar means the same shape but different size, but the sides have to be proportional. And since both of these proportions reduce to that same amount of 150 over 1, we can say they're proportional with the same slope of 150 over 1.